Then mobile satellite services, GSM. So services and architecture. If your work involves some form of wireless public communications, you are likely to encounter the GSM standards. So initially developed to support a standardized approach to digital cellular communications in Europe, the global system for mobile communications protocols are rapidly being adopted to the next generation of wireless telecommunication systems. In the US, its main competition appears to be the cellular TDMA systems based on the IS-54 Indian standards. So since the GSM systems consist of a wide range of components, standards and protocols. So you have the diagram of it. So SMS via GSM phone or modem, GFI events manager machine with the connected GSM phone modem, SMS center, the tablet PC with SMS gateway, that is the personal assistant, directory assistant, pager, recipient. So these are all you studied in a GSM, that is wireless networks, laptop with the SMS gateway, GSM cell phone, everything. So GSM architecture overview. So you have a mobile station, air interface, okay. Then you have a station. This is base terminal network, okay, base terminal station, transmitter, base station center, okay. Now this is ABS interface, then A interface. This is public service telephone network. Now this is variable length reduction. You have OMC, HLR, AUC, NSS, that is node service center. Okay, so the mobile service center is connected to all these things. Now the communication based on this base terminal service to the network service station with the connectivity of the public service telephone network. So the GSM and its comparison standard DCS 1800 for the UK, where the 900 megahertz frequencies are not available for GSM, have been developed over the last decade to allow cellular communication systems to move beyond the limitations posed by the older analog systems. Analog system capacities are being stressed with more users that can be effectively supported by the available frequency allocations. Compatibility between types of systems had been limited if non-existent. By using digital encoding technique, more users can share the same frequencies than had been available in the analog systems. As compared to the digital cellular systems in US, so you have code division multiple access and time division multiple access. The GSM market has had impressive success. Estimates of the numbers of telephones run from 7.5 million GSM phones to 0.5 million IS-54 phones to 0.3 million for IS-95. So the main thing is here, what is the analog system capacity? How many users can share this one? So GSM has gained in acceptance from its initial beginning in Europe to other parts of the world, including Australia, New Zealand, countries in Middle East and the Far East. So the cellular frequencies 900 megahertz for GSM, 1800 megahertz for DCS 1800 portions of the GSM signaling protocols are finding their way into the newly developing PCS and LEO satellite communication systems. So the frequencies and the link characteristics of these systems differ from the standard GSM air interface. All of these systems must deal with users roaming from one cell to another, satellite or beam, that is smaller beams, and bridge services to public communication network, including public switch telephone network and public data networks, BDN. GSM architecture includes several subsystems: mobile station, And these digital telephone includes vehicle, portable, and handheld devices. A device called subscriber identity module (SIM), you know it, that is basically a smart card, provides custom information about users such as the services they have subscribed to and their identification on the network. The base station subsystem, that is base station service. Okay, so the base station service is the collection of devices that support the switch network radio interface. Major components of BSS include base transceiver system that consists of radio modems and antenna equipment. In OSI term, the BTS provides the physical interface to the mobile station, where the BSC is responsible for the link layer services to the mobile station. Logically, the transcoding equipment is in the BTS base transceiver station, however, an additional component. So this architecture already we saw. The network and the switching subsystem, NSS, network switching service. The NSS provides the switching between the GSM subsystem and external networks along with the databases used for additional subscriber and mobility management. So network service switching subsystem provides switching between the GSM subsystem and external network. Major components in the NSS include mobile services switching center, home and visiting location registers. The HLR and VLR databases are interconnected through the telecom standard signaling system 7, that is a control network. Then OSS is the operation subsystem. This provides the support functions responsible for the management of network maintenance and services. The components of the OSS are responsible for network operation and maintenance, mobile equipment management, and subscription management and charging. So this is the example of this: corporate headquarters, internet, teleport, PSTN, central office. This is business continuity. You have the router. So many the NSS, emergency response, enterprise, how it is linked with the satellite. So here several channels are used in the air interface. So FCCH, the frequency correlation channel, provides frequency synchronization. What is the purpose of FCCH? SCH, synchronization channel. So this is FCCH burst 8 bits later, provides a reference to all slots on a given frequency. PAGCH, paging and access grant channel, used for the transmission of paging information requesting the setup of a call to the mobile station. RACH, random access channel. So this is used for avoiding collisions. CBCH, cell broadcast channel. So used for infrequent transmission of broadcast by the ground network. BCCH, broadcast control channel, provides access status information to the mobile station. FACCH, fast associated control channel for the control of handovers. TCH, full rate, half rate, traffic channel for speech at 13 kilobits per second or data at 12.6 or 3.6 kilobits per second. Similarly for half rate, that is 7 kilobits per second, or data at 6 or 3.6 kilobits per second. So GSM service security. So GSM was designed with a moderate level of service security. So several cryptographic algorithms for security. So A51, A52, A53 streams ciphertext are used for ensuring over-the-air voice privacy. GSM uses general packet radio service for data transmission like browsing the web. So the most common